Today we're going to talk about a special case with factoring, and that's when you factor a perfect square trinomial. So let's just talk about, first of all, what a perfect square is. We know from before that a perfect square would be a single value when you square it, will equal that number. So in the case of 64, that would be 8. Or in the case of 25, that would be 5. Okay? So if we go ahead and look at what happens when we square a binomial, okay, first of all, the common misconception is all you have to do is square the first term and then square the second term. But that actually is incorrect. Okay, you can't do that. You have to square, you have to do FOIL on this in order to do it properly. So let's rewrite this again. A plus 3 squared would equal a plus 3 times a plus 3. And then we would have to FOIL it. So if we FOIL it, a times a is a squared, and the outer, which would be 3a, and the inner, which would also be 3a, and then the last two, which would be 9. Okay, so for a final answer of a squared plus 6a plus 9, okay, and you can see how this leaves out our middle term. Okay, so that's why you can't just square the first one and square the second one. You actually have to FOIL it, and then when you FOIL it, you'll have your outer and your inner that then you add together. Okay, and then you get a trinomial because it has 3 terms. Okay, so we could generalize this so that we can maybe take a shortcut and not have to FOIL. And here's what the shortcut would be. If we say, okay, well, any perfect square is going to be of this form, where you have one term plus another term, and then you are squaring that, then what it will end up being is you're going to square the first one, and then you're going to take twice a times b, so the first one times the second one, plus the second one squared. Okay, and you can see that that worked out for the problem that we just did, because what we did was we squared the a and got a squared. Then we took twice a times b, so 2 times a times 3, which would be 6, and then we squared the last one, so that's your b squared. Okay, so that's a shortcut that you can do instead of having to do FOIL, is follow this formula here for these perfect square trinomials. Okay, so if we look at this 2x minus 3 in parentheses squared, so what does this mean? Some students might get it kind of confused and go, okay, I just have to square the 2x and I'll get 4x squared, and I square the negative 3 and I get 9, and I'm done. But actually, no, that's not the way you do it. That's the wrong answer, okay? What you have to do is you have to rewrite this as 2x minus 3 times 2x minus 3, okay? Because that's what 2x minus 3 quantity squared means, and go ahead and FOIL it. So if we FOILed this, did the first two, we would get 4x squared. If we do the outer two, we would get minus 6x. If we do the inner two, we would get another minus 6x. And then if we do the last two, we would get negative 3 times negative 3, which is a positive 9. Okay? So to rewrite this, it would be 4x squared minus 12x plus 9. Okay, so that's an example of a perfect square trinomial, because if I were to now find the factors of this, then guess what I would get? I would get this back. Okay, So this is considered to be a perfect square trinomial, and the way that you can kind of tell is look at this. Is this a perfect square? Is that a perfect square? If so, then likelihood is it could be a perfect square trinomial. You're not going to be 100% sure that it's going to work out until you try it. Okay, so let's do another example. Okay, and let's see if our formula from the first page will work out. Remember that formula was a squared plus 2ab plus b squared. And let's see if we would get this if we do that. So if we square the first, okay, 2x quantity squared would be 4x squared. Okay, so 4x squared. And then we take twice 2x times negative 3. So twice 2x would be 4x times negative 3 would be negative 12x. And negative 3 squared would be 9. Okay? So yeah, so basically what using this formula will do for you is it just allows you to take a little bit of a shortcut when you have a perfect square, and instead of having to FOIL, you can just go straight to this final answer. Okay, so let's look at this one. Could this one possibly be a perfect square trinomial? And the answer is no, okay? Because while this is a perfect square, you know, this is not a perfect square, okay? 15 is not. So that's not a perfect square trinomial. If we do another example, and let's try 16n squared minus 24n plus 9. That could be a perfect square trinomial because this is a perfect square and that's a perfect square. What we're just not sure of is will we get these to add up to a negative 24 in the middle. So the only way to find out is to just go ahead and factor it and see if it's a perfect square or not. And so what we could do is then say, all right, remember we need factors of a times c. So a times c, which is 16 times 9, which is, let's see, 144. And they have to add up to negative 24. Okay? So it looks like we're looking for the pair negative 12 and negative 12. Because negative 12 times negative 12 would add up to 144. Or excuse me, multiply together to be 144 and add up to a negative 24. So we're going to replace the negative 24 with these two numbers here and see what happens. So let's see, we're going to do 16n squared minus 12n minus 12n plus 9. All right, and then we will group them, do a plus negative there, okay, and pull out GCFs. So the GCF of the first binomial would be 4n times 4n minus 3. And then the GCF of the second one would be a, hold on, I need to erase got that parentheses too close there. It would be a negative 3. So we'll put minus 3, and then it'd be 4n minus 3. Okay, so then we end up with 4n minus 3, because that's this and this, and then another 4n minus 3, because that's what's inside the parentheses. So yes, this did turn out to be a perfect square trinomial because we got the same, the factors were the same. So this could be rewritten as 4n minus 3 quantity squared. Okay? So, you know, how could we have found that out without having to go through all that? Well, we would take the square root of the first term, so the square root of 16n squared, that would be 4n. So 4n. and the square root of 9, which comes from here, and that's 3. And if we take twice that, 2 times 4n is 8n, and 8n times 3 is 24n, then if we get that middle term, these middle terms match, then we know that this is a perfect square trinomial. So let me go through that one more time how I did that. I took the square root of the first term, 16n squared, and got 4n. So the square root of this was 4n. The square root of this was 3. And then I take twice that. So if twice the square root of the first term plus or times the square root of the third term is, when I multiply it together, if that's the middle term, if it matches, then this is a perfect square trinomial.